In section 1.1, we have some learning objectives. We would like to evaluate algebraic expressions, and we want to learn to use exponents. Some of these things may already be pretty familiar to you. And the key vocabulary for this section is a variable, and a variable is a letter that we put in place of an unknown value. And the reason it's called a variable is because the value may vary. So it can be of variable different values depending on what it is we're trying to do. And an algebraic expression is a collection of numbers, letters, operation signs that represent a situation. That's what an algebraic expression is. Now, it's not an equation because it also would not have an equal sign. So something like 3x minus 2, this would be an algebraic expression. It's an expression, not an equation, because there's no equal sign. There aren't two sides to an expression. There's just the item itself. In this case, x would be the variable. And when we talk about powers, we could have something like 5 to the 4th power. This collectively is a power. And 5 is the base of the power. And 4, in this case, is the exponent. Okay, so that's a quick overview of the vocabulary we'll be using and some basic ideas about algebraic expressions and powers. When we start looking at, again, algebraic expressions, an algebraic expression or variable expression is an expression that includes at least one variable. These are all algebraic expressions. A variable is a letter used to represent one or more numbers. The numbers are the values of the variable. And then you can see that 5n means 5 times n, and the operation we're describing here is multiplication. So sometimes it's denoted with a dot, and sometimes they just put the coefficient with the variable, and that indicates that we should multiply. When we set up 14 divided by y, we have a fraction. That means 14 divided by y. We're looking at division. 6 plus c is going to involve addition, obviously, and 8 minus x is going to involve subtraction. So when we go ahead and evaluating an algebraic expression, when my variable has a defined value. So if I'm going to evaluate w minus 8 when w is equal to 20, I'm going to substitute 20 in for the w. So 20 minus 8 would be 12. So the value of w minus 8 when w is equal to 20 is 12. This is what we'd call evaluating an algebraic expression. So y minus 1/2 when y is equal to 5/6, I plug 5/6 in for y. Minus 1/2, I'll need common denominators. 1/2 is 3/6. So 5/6 minus 3/6 would be 2/6, which simplifies to be 1/3. Okay, so that's evaluating algebraic expressions. When we have something expressed in this form in sort of a real-world descriptive, we want to evaluate an expression, but we may or may not have the expression. So let's read the problem. The total cost of seeing a movie at a theater can be represented by the expression A plus R. So I do have the expression A plus R, where A is the cost in dollars of admission and R is the cost in dollars of refreshments. So if I pay $7.50 for admission, that means A, the value for A is going to be $7.50. And $7.25 for refreshments, that means the value of R is going to be $7.25. Find the total cost. I plug $7.50 in for A and $7.25 in for R, and I'll end up with $14.75 for my total cost. Okay, if we want to write the power in words and as a product, so this would be, if I wanted to write it in words, it would be t to the 4th power. If I wanted to write it as a product, what this means is 4 t's multiplied together. It would be t times t times t times t. So the exponent really represents multiple multiplication events using the same value. Okay, so in this case there were 4 t's being multiplied together. Here I would have 8 1/2s multiplied together. So this would be 1/2 to the 8th power if I wanted to write it in words. And that would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. 1, 2, 3, 4, 5, 6. Uh-oh, I'm short. Times 1/2 times 1/2. So 1, 2, 3, 4, 5, 6, 7, 8. And that's times. Okay, so powers can be written as products. And it's important that we learn how to use the vocabulary of mathematics to describe these things. If you see this, it's read 1/2 to the 8th power. Okay, if I want to evaluate the power, now I actually want to find that value. So 11 to the 3rd power is 11 times 11 times 11. I could use a calculator, or I could say I know 11 times 11 is 121. And when I multiply that times 11, I'm going to get 121, 1210, 1, 3, 3, 1. That's the value. Okay, 1/6 to the 3rd power. I know that's going to be 1/6 times, sorry, I wrote 1/2. 1/6 times 1/6 times 1/6. And when I multiply fractions, I'll have numerators times numerators. 1 times 1 times 1 is 1. And 6 times 6 times 6 is 36 times 6, which would be 36 and 18. That's 216. Okay, so 1/216th would be that value. Okay, and working on a multi-step problem, I'm buying a tank to hold 3 fish. I have a flame angel that is 3.5 inches long. Okay, that's important, 3.5 inches long. A yellow sailfin tang that is 5.5 inches long. And a coral beauty that is 3 inches long. The area in square inches of water surface, the fish need is given by the expression 12F, where F is the sum of the lengths in inches of all the fish in the tank. What is the total length of the 3 fish? I have 3.5 plus 5.5 plus 3. So 3.5 plus 5.5 is 9, plus 3 is 12 inches. If I want to know how many square inches of water surface the fish need, I can use 12F, but F is 12 inches, so I'd have 12 times 12 inches, and that's 144 inches. Okay, so that's it for section 1.1. In class, we'll working on your homework and doing some more exploration of these ideas.